Dividing into squares. This is one of my favorite activities. About 11 years ago, I was in a session for math teachers interested in becoming math coaches. Dan Guilfoy, part of the math team in Halifax back then, facilitated this dividing into squares investigation with the group. I loved it so much that I workshopped it a little into a more complete lesson that would be suitable for my students, and I've been doing this lesson on the first day of school with my grade 8s every year since. What I love about this activity is that it's super fun. All students can participate. It's not speed or numbers driven. It emphasizes some different areas of math like spatial awareness, noticing, extending, and articulating patterns, which means a different bunch of kids have a turn to be the rock stars, which is nice. And because it requires some trial and error and tenacity, it can tell you a lot about your students as problem solvers and shows them how your class operates. I usually start by telling students, I don't really know what your math knowledge is yet, but this activity requires that we can all tell the difference between squares and rectangles. This comment usually puts the students at ease. This is easy. I write squares on the board and ask that students raise their hand if you can tell me one thing that you know to be true about squares. I take answers from volunteers one at a time and record their comments up on the board. We stop and discuss any vocabulary that comes up. This is a typical list. I might have to ask questions like, what about things that are parallel or perpendicular to get these comments? And I might push a little, what about symmetry, to get the last two. Next, I write rectangles on the board. We go through the list we made for squares and decide if the statement is also true for rectangles or what we would need to change to make it true. At this point, I ask if we all feel pretty confident that we can recognize a square if we see one, or if we can tell the difference between a square and a rectangle. We are now ready for the dividing into squares activity. I keep the instructions simple. We are going to be given a paper with some squares on it. You have to draw in some lines to divide the square into the number of squares written underneath it. And then I do an example for them on the board. For this example, I have 16 written underneath the square. So that means I want to divide the square into 16 squares total. And that could look something like this. I want to be clear about something else as well. We talk about, what about this square here in green? Or these squares, would they count? And we say no, that overlapping is not something that we can do. So the only answer for this would be 16. It is only 16 squares. I give each student a piece of paper that kind of looks like this. Theirs is just on plain paper with the numbers underneath. I have them in blue here so they're easier to see. I have lots of extras ready. Remind them to use a pencil and that mistakes and messiness is possible and expected, so have their eraser ready. I usually have given everyone one of these at the start of the day to emphasize my expectations that in math we make lots of mistakes and that's how we learn important things. Then I pass out the worksheet. I ask students to work quietly on their own. I tell them how good it feels to figure out things for yourself and to work independently for now. I ask that they don't ask questions because that might give away some answers, and not to worry, I'll be giving them some hints if they need them as we go. And completing these squares in any order that makes sense to them is okay. If you haven't tried this activity before, try it on your own first. Trust me, anytime you can do the activity for yourself before knowing the answers will give you more insight into the stumbling blocks your students might have and how you might tailor this activity to be appropriate for your students. So pause it right here if you like to try some of these on your own. I use my LCD to project the squares on my whiteboard. Most students get the answers for 4 and 9 right away, and I might fill those in on the board. I also write the numbers in the squares. I won't do that here anymore because it looks really busy, but I do this on the whiteboard in my classroom as we go. Next, I see a lot of this. I might ask students individually, are these squares or rectangles? If I see a lot of this error, and I usually do, I might draw this on the board and ask students if this would be a solution, why or why not. Someone will usually tell us it's rectangles, so we know that this one doesn't work. There are some students that can get the actual answer for 6, 7, and others without any hints, but I try to gauge the room, and when I feel just the right level of frustration, I say I'm going to give you a hint. Without saying anything, I draw in the solution for 7. Then there's a flurry of activity. For some kids, they can get a lot of the others from here. Other students need more help, but I wait a healthy chunk of time again to max out their efforts before I tell them that I'm going to give them another hint. This time I direct their attention to 2 of the ones we know. I ask, what is the increase from 4 to 7? And they can all tell me it's 3. I ask, well, how did we increase by 3? Someone can usually tell me that we made a window in one of the squares. With a brief discussion, we can get to a generalization that in order to increase the total number of squares by 3, we have to take one square and make it 4. From there, students start up again. Some can then look for other places that have a jump of 3. Some need to be directed to look for other jumps of 3 or spots where we increase by 3. Again, that might be an individual chat or a class hint, depending on your group. From my experience, most students can get 10, 12, and 13 with that hint. 6, 8, and 11 seem to be the trickiest. When the pencils start to slow down, I might remind them of our current strategy. To increase the number of squares by 3, take one square and turn it into 4 by making a window, as the kids say. I might point out that the difference between 9 and 6 is 3. What would our strategy be in reverse? This time, we want to decrease by 3 squares instead of increase by 3. Usually, I have someone in the class that can say, instead of take one square and make 4, take 4 squares or a window and make 1. From here, while some are finishing, I might get others to come up and draw in what they figured out. We talk about alternate solutions for some of the squares. If I have students that finish before others and I want everyone to have lots of think time, I ask students to see how many solutions they can find for each square, and we get lots of those on the board as well. We talk about the order they completed the squares in and what they were thinking about, mistakes we made and how we knew it was a mistake. We talk about the most common errors and what hints helped. We also take time to talk about what area of math this is and what experiences you may have had already that might lead you to excel at this activity. What are other places we see this kind of skill showing up in our daily lives? We talk about problem solving, managing frustration, sticking with a problem, trying new ideas, and what made us successful and what we still need to work on. It always impresses me how candid students can be in these moments, telling me they weren't afraid to make mistakes because everyone was erasing. They kept working on it and knew the hints were coming. I asked them too what I did that helped or wasn't right for them, making a point of listening and accepting feedback on my facilitation, which they always seem to appreciate. Basically, a fun activity and a great conversation. I'd love to hear if this activity works for you or what changes you made to make it work for your students. Email me with any questions or feedback. Thanks for listening.